CL2R cable is most likely a typo and should be referred to as Class 2 riser cable. The rationale behind this conclusion lies in the consistency of cable classifications within the Class 2 category. All other CL2 cables are explicitly designated as Class 2, so it is logical to assume that CL2R follows this pattern. The abbreviation CL2 typically signifies a Class 2 cable, which is a type of wiring used in low voltage and power limited circuits. These circuits are commonly found in applications such as security systems, thermostats, and other control circuits where the voltage and current are limited to reduce the risk of electrical shock and fire. The Class 2 designation is important because it indicates that the cable has been designed and tested to meet specific safety standards for these types of applications. These standards typically include requirements for insulation, flammability, and current carrying capacity. The R designation in CL2R indicates that the cable is suitable for riser applications, which means it can be installed vertically in a building, such as between floors. Riser cables are designed to prevent the spread of fire from one floor to another, and they typically have a higher fire resistance rating than general-purpose cables. Therefore, CL2R cable is a Class 2 cable that is specifically designed for riser applications. The erroneous definition of CL2R as conductive optical fiber riser cable is inconsistent with the established naming conventions for CL2 cables. Furthermore, the term OFCR, also defined as conductive optical fiber riser cable, is not a recognized cable type in industry standards or common practice. This further supports the assertion that the CL2R definition is a typographical error. In the context of low voltage and power limited systems, understanding cable types and their proper applications is crucial for ensuring safety and compliance with electrical codes. Class 2 cables are specifically designed for these types of systems and offer a level of protection against electrical hazards. When working with low voltage and power limited systems, it is essential to select the correct type of cable for the application. The cable must be rated for the voltage and current of the circuit, and it must be suitable for the environment in which it will be installed. For example, if the cable will be exposed to moisture, it must be rated for wet locations. If the cable will be installed in a riser application, it must be a riser-rated cable. The National Electrical Code, or NEC, provides detailed requirements for the installation of electrical wiring, including Class 2 cables. The NEC specifies the types of cables that are permitted for different applications, as well as the methods for installing and supporting the cables. It is important to consult the NEC and any other applicable codes and standards before installing any electrical wiring. The NEC Article 725 covers Class 2 and Class 3 remote control, signaling, and power limited circuits. This article provides requirements for the wiring methods, overcurrent protection, and grounding of these circuits. It also specifies the types of cables that are permitted for use in these circuits. The specific requirements for Class 2 cables are found in NEC Section 725.52 and 725.135. These sections cover the listing and marking requirements for Class 2 cables, as well as the requirements for installing the cables in raceways and other enclosures. The NEC also provides tables that specify the ampacity of different types of conductors. Ampacity refers to a maximum amount of current that a conductor can carry without exceeding its temperature rating. The ampacity of a conductor depends on its size, insulation type, and the ambient temperature. It is important to select conductors with adequate ampacity for the circuit in which they will be used. The NEC Table 310.15b16 provides ampacity ratings for various types of conductors based on their size and insulation type. This table is an essential resource for determining the appropriate conductor size for a given circuit. In addition to the NEC, other standards and guidelines may apply to the installation of Class 2 cables. For example, the Telecommunications Industry Association, or TIE, publishes standards for cabling systems used in commercial buildings. These standards may include requirements for the performance and installation of Class 2 cables used in communication circuits. When working with electrical wiring, it is always important to follow safe work practices. This includes wearing appropriate personal protective equipment such as safety glasses and gloves, and energizing circuits before working on them. It is also important to use proper tools and techniques to avoid damaging the wiring or equipment. If you are not familiar with electrical wiring practices, it is best to consult with a qualified electrician. Electrical work can be dangerous, and it is important to take precautions to protect yourself and others from electrical hazards. In summary, the definition of CL2R as conductive optical fiber riser cable is most likely a typo and should be Class 2 riser cable. OFCR is not a recognized cable type. Understanding cable types and their proper applications is crucial for ensuring safety and compliance with electrical codes. When working with low voltage and power limited systems, it is essential to select the correct type of cable for the application and to follow safe work practices. Always consult the NEC and any other applicable codes and standards before installing any electrical wiring. Class 2 cables are specifically designed for low voltage and power limited circuits, offering protection against electrical hazards when installed correctly and in accordance with relevant safety standards. Remember to prioritize safety and consult with qualified professionals when dealing with electrical installations.